polynomials is basically reverse of what we did yesterday. So yesterday I gave you a polynomial function, and then you created a list of possible solutions. You guessed and checked until you found a 0, and then you kept going until you got it to be quadratic, so you could factor a quadratic formula. And then at the very end, you could solve for more zeros, and you told me this list of zeros: -1, 5, and 6. Right? Okay. Today, I give you the zeros. The zeros are -1, 5, and 6. Give me the polynomial.
That's easy.
Yeah, it is.
You just distribute.
Yes. Ooh, this is out of order. This.
Try.
We'll go back to that one. Writing polynomial functions. Use the zeros to write the factors. So, like, I'm going off of Andrew's question from the homework, because we know the solutions you guys told us were 5, 6, and -1. If 5 was the solution, what did the factor look like?
X minus 5.
It must have been x minus 5. If 6 was the solution, what did the factor look like? X minus 6. And if -1 was the solution, the factor was x plus 1. Right? So you write the factors out. In pre-calculus, you'll talk about those as linear factors. Write them as linear factors. And then TJ said, don't you just distribute? Yes. So you write out your factors, then you distribute, or multiply. Now, we already learned how to multiply polynomials back in section 4.2. So most of what I'm teaching you today is about like how to write the polynomial, so how to go back with the linear factor. And then we're going to have some we're going to have some work with irrational solutions or irrational zeros. Those are a little bit more challenging to expand. So we'll talk about those. But we really just want to multiply, combine like terms, and write our polynomial in standard form. So everybody's answer will look the same, because we'll have highest exponent down to the lowest exponent in descending order. The one thing I will say is be really careful here with your signs and your multiplication. You know, one small sign error where you multiply and you get a plus and it's really supposed to be a minus is going to lead to a wrong term in your final standard form. Or I don't know what it is about multiplying polynomials, but when I have people doing their distribution multiplying polynomials, I get a lot of like bad multiplication that's really easy. So like 2 times 3 is 6, not 5. Or 3 times 3 is 9, not 6. Okay? But like those are small little traps that people will fall into, and you just have to be really careful that like when you're distributing, you're multiplying, not adding. You do add the exponents, right? I think that might be where some stuff gets muddled. It's like if you're taking x cubed times x squared, it's x to the 5th. So just be really, really careful with signs and multiplication. Okay. So here's an example to start with. We're going to write the polynomial that has the zeros -3, 1, nope, +3, -1, and 5. This problem that I'm giving you now is basically like the answers that you gave me yesterday. Yesterday you said, hey, the zeros are 3, -1, 5, I'm done. Now I'm saying, let me give you the answers and you work it back to give me the problem that it started from. What do you know about the degree of the polynomial?
It's going to be like cubic.
How did you know it's going to be cubic?
There's 3 x's.
There's 3 total solutions, right? The total number of solutions is equal to the degree. So you can kind of check your work and make sure you're on the right track, because you should get a cubic polynomial. So I'm going to write this out in its factored form. This is f of x equals, if 3 is a 0, what does my factor look like? Oh, thank you, x minus 3. And then x plus 1 and x minus 5. So building off of that we talked about in regards to Andrew's homework problem. Now, this is not your final answer because it's a polynomial written in factored form, and we want a polynomial in its standard form, so you have to multiply. Remember from section 4.2, if you have 3 factors, you can't multiply 3 things at once, so you have to do 2 at a time. I will say, I like to multiply the last 2. You can go in any order that you want, but I always multiply the last 2 together because then I just multiply a binomial in front times a trinomial in back, and I like to do it that way. If you don't care, it doesn't matter what order you multiply. Okay. So I'm going to FOIL this out, and you guys have FOILed so many times since Algebra 1 that I'm going to take out some of the work of my FOIL, right? I'm going to do some of the work in my head, so I'm doing a little bit of mental math here. First terms, x times x is x squared. Mental math. The outside term is x times negative 5. So that's negative 5x. The inside term is positive 1 times x, so that's plus 1x. So I have negative 5x plus 1x. So I'm going to write minus 4x. And then I'm going to do last terms, positive 1 times negative 5 is negative 5. How many people already do that kind of mental math when they FOIL? Okay? A large number of us are already doing that. Now, on a quiz or a test, I might actually write out all my terms because I'd want to show my work, partial credit, could make a small mistake, right? But a lot of times when I'm doing math, I'll take a little bit of shortcut. Now, if you can't do that because you can't keep track of all 4 terms of FOIL, then you should write everything out, and that's totally okay. Now, you're not done here because this is only quadratic. You still have to multiply by x minus 3. So again, this is a problem from section 4.2. We already know how to multiply a binomial times a trinomial. Move the page here. Distribute the x to every term. So I'll get x cubed minus 4x squared minus 5x. Distribute the negative 3 to every term. Negative 3x squared plus 12x plus 15. And remember, I like to stack my like terms when I'm doing that, just because it makes it really easy. So my final polynomial is f of x equals x cubed minus 7x squared plus 7x plus 15.
That's our homework going to be?
Yeah. Now, do you agree that the answer for today looks like the problem from yesterday? Yeah. Here's a polynomial, f of x equals x cubed minus 7x squared plus 7x plus 15. Find all the solutions. And you would start with a list of rational zeros. So you do plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. And you could start guess and checking with synthetic. And you'd find 3, negative 1, and 5 eventually. Okay. So we're just doing the opposite of what we did yesterday. I think today is easier. What do you think? Yeah. Okay. So there are some special cases, and we want to get into those. Before we do that, I'm going to have you do one example on your own. So I'm going to go back to now you try. Could you please write the polynomial with the zeros negative 2, 3, and negative 3? Happened in this problem, if you set it up the way that I did, I wrote it x plus 2, x minus 3, and x plus 3. And I saw most people did it sort of the same way I did, but a few people preferred to multiply the first 2, which is totally fine. Okay. But something very interesting happens with x minus 3 and x plus 3. What happens with those when you multiply them out? The x's cancel out, the outside and the inside. This is really x squared minus 9. And doesn't that agree with like our difference of perfect squares? You have 2 factors, one is plus, one is minus, but they're exactly the same. So they should give us a difference of perfect squares right there. Okay, so that's x squared minus 9. And then we have x plus 2 left over. FOIL this out, and we're going to get x cubed plus 2x squared minus 9x, and then minus 18. And nothing is a like term, so then I have a 4-term cubic polynomial. some people were missing a term as I was walking around. And so see if you can find out where you missed it. Now, if you multiplied like x plus 2 times x minus 3 first, you should still end up with the same final answer. So if you have a different answer than this one, I'd go back and just kind of look at your work. Can you find a small mistake, like the mistakes I'm talking about? Sign error, small multiplication. Did you write out the factors correctly? Those can be issues for us. Does anybody have any questions on this example? Okay. I want you to keep this x minus 3, x plus 3, turning into x squared minus 9 in the back of your head, because we're going to use it for the next type of problem. Okay, we have something called an irrational conjugates theorem.
Something like this was on the slide.
What?
It was weird. It was like, if, something like this, if then it had like some equation you had to plug it in, and none of it was. Oh, yeah. You know what I'm talking about?
That sounds very descriptive, but I'm not quite sure I'm following you.
I had no idea.
Do you remember anything more about it? I'd be curious to know.
Something about square root.
It was like this, I guess, because it's on boxes on it.
Yeah, it was a box.
It was like
A box B.
and it was really weird.
It was like A box B, and then you had to plug that in.
But mine didn't let me plug in anything. Write the answer.
Yeah, it was like plug A box B equals something.
You just had to
I bet I know what you,
find it.
I bet it was just like a substitution, like they made something up, right? The ACT does that, gives you weird notation that doesn't really mean anything. Could that be it?
There was like on the ACT and the actual ACT, they have like a square root with a number in it with like an N over the square root.
Oh yeah, that's our next chapter.
That really,
Oh, that's interesting.
there was like
Okay.
3 of mine. So
Is that supposed to be a square root of B?
Yeah. I'd be curious, if you can write down what you're picturing was on your screen for Aspire, I'd love to see it.
I think it was something called like a functions machine. It said find like the combination of numbers that would work.
No, I found that one was different. I got
Yeah, because some people did have certain problems on their map.
They had like 100 and they just picked like, this person gets 50, this person gets 2, other person.
That's interesting. Okay. If a plus the square root of b is a 0, then it must be true that a minus the square root of b is also a 0. Do you remember talking about conjugates back in chapter 3 with the imaginary numbers, complex numbers? And the conjugates in complex numbers were a plus bi and a minus bi. So this is very similar. The conjugate is kind of the same idea. It's a plus the square root of b and a minus the square root of b. So the only thing that changes is the plus or minus sign in between the two terms. Okay. So this is saying that when you have an irrational solution to a polynomial, they always come in pairs. If you have one, you have the other one automatically. So they come in groups of 2. And if you think about the way that we would solve and get an irrational solution, that makes a lot of sense. Like think about x squared minus 5. If that was one of your factors, you would set x squared minus 5 equal to 0. You'd add 5 to both sides to get x squared equals 5. And then you take the square root of both sides. And what do you have to add every time you take the square root? To solve. X squared equals 5. Take the square root of both sides. What do you add to your answer? Plus or minus. So automatically, you just made it a pair, right? And if you think about the quadratic formula, if you have a positive discriminant that's not a perfect square, you'll get an irrational solution. And in the quadratic formula is the opposite of b plus or minus the square root. So it's impossible to get one square root and not the other. They have to come in pairs. CJ? I was on a roll. I can't just stop when I'm on a roll, right? Okay, here's an example. Write the polynomial with zeros, 0 and square root 7. How many zeros am I giving you? 2. How many must there actually be? 3. 0 is fine all by itself. It's not irrational. However, the square root of 7 is there. What also needs to be there? It must be, if there's a positive square root of 7, there's also a negative square root of 7. So I'm going to say, since square root of 7 is a solution, then negative square root of 7 is also a solution. Are we okay with that statement?
If it's negative square root of 7 and positive.
Yes. Yes. Okay, now let's write the factors. What can we write for a factor when our 0 is 0? What does the factor look like? It could just be x. I mean, it is x minus 0, but do we have to write x minus 0? No. And Hannah remembers from examples that we did when we got answers of 0, it was just x equals 0, right? Okay, so we'll call x. And then, since square root of 7 is a 0, we should have an x minus the square root of 7. Is that okay with you? And an x plus the square root of 7. So these always come in pairs. And then I want you to think about how those last two factors, x minus the square root of 7 and x plus the square root of 7, how the structure of those two factors is so similar to x plus 3, x minus 3. They're exactly the same except one is plus and one is minus. So what's going to happen to your outside and your inside terms? They're going to cancel out again. Okay? So when I FOIL this out, and I'm going to do a little bit of mental math again, my first term, x times x, is going to be x squared. But I know that x times positive square root of 7 is going to cancel with x times negative square root of 7. They're the same but different signs, so they're gone. And then my last one is just a negative square root of 7 times a positive square root of 7. What do you get when you take negative square root of 7 times positive square root of 7? Negative square root of 49, which is 7. Okay, let's talk this through. Do you agree that a negative times a positive will be a negative?
Yes.
Yes. Okay, now think about square root 7 times square root 7. When you take a square root times itself, what do you get?
The number that
The number that's underneath, right? So it's just going to be 7. You can also think about it like the square root of 7 times the square root of 7 is really the square root of 49, which is 7. Okay? So we have x squared minus 7. Now, I'm going to stop before we continue multiplying, and I'm going to say, doesn't that make sense? If you were like factoring and you had a factor of x squared minus 7, you would set that equal to 0. You would add 7 to both sides. And then you would take the square root, and anytime you take the square root to solve, you'd add a plus or minus square root of 7. So doesn't that seem to agree? This factor x squared minus 7 really does work. Okay. And then we still have to distribute the x. So our final answer will be something like f of x equals x cubed minus 7x. Questions on that? Okay. Now, everybody make sure you got your thinking caps on. You're alert, you're awake, you're participating. You're thinking, you're asking questions, and you're writing things down. It's not as bad as I'm making it out to sound, but you have to be alert. Let's write the polynomial if the zeros are 2 and 1 minus the square root of 3. 2 is fine, right? You can have just 2 and not have to have negative 2. Do you agree? But when you have an irrational solution like 1 minus the square root of 3, it can't come by itself. What is also a solution here? just positive square root of 3?
Plus minus.
1 plus square root of 3. This is like a minus square root b. So if a minus square root b is a solution, what else is a solution? A plus square root b. So we still need to keep the 1. So we're going to have a 1 plus the square root of 3. Are we all okay with that? Conjugates? Okay. Now, let's write out our factors for our polynomial. First one, not bad, x minus 2. Now I'm going to introduce a double set of parentheses here. So I'm going to open my parentheses for my next factor. Should be x, right? And then usually I'm subtracting the number that is the solution. Like when it's 2, I'm doing x minus 2. Okay. So I'm going to do x minus, but I want to subtract all of this irrational solution, 1 minus square root 3. So what do I use to say all of something in math?
Parentheses.
Parentheses. So I'm going to put that in parentheses. I make that really small only so like it's easier to see like my big parentheses for the factor and my small parentheses for the irrational number.
Couldn't you just distribute?
I'm going to. I'm not there yet. Okay, so are we okay with that? That's x minus that 1, 0. And then we have to do it to the other one too. So it will be x minus all of 1 plus the square root of 3. So I have something like this. Cool? Okay. Now, I agree with Trevor. Why not distribute? Okay. And one thing to note here is this one right now, as it is not just like x plus 3, x minus 3, right? It's different because you're subtracting both of them and they're different numbers. And it's not like x minus square root 7 and x plus square root 7 because they're both subtracting and they're different numbers. But let's distribute and see what happens. So we'll distribute our negative in both groups. You should come up with 2 groups of parentheses, x minus 1 plus square root 3, x minus 1 minus square root 3. Can you think about regrouping those so it is more like x minus square root 7 and x plus square root 7? Which 2 terms should be grouped together?
With the square root 3 cancel.
What do you mean?
Because 1's plus and 1's minus.
Do you see that? How now when we distribute the negative, now you have a plus square root of 3 and a minus square root of 3? Which is really similar to what we had in the previous example, right? A minus square root of 7 and a plus square root of 7. And then look at what's in front of both of them. Not just 1, but x minus 1. Regroup it. Are you allowed to do that? Associative property, yes you are. You are allowed to regroup. So now, I see it as I'm taking x minus 1 times x minus 1, and that's sort of replacing like the x times x up above. So if I were to FOIL this out, and I'm going to treat these like whole terms, x minus 1 times x minus 1 would be x minus 1 squared. You okay with that? Now I'm going to show all my work for FOIL. X minus 1 times a negative square root of 3 would be something like negative square root of 3 times x minus 1. Are you okay with that? Just distributing x minus 1. And then I'm gonna distribute a square root of 3 times x minus 1. And what do you notice? They cancel each other out. One's a minus and one's a plus, and they're exactly the same product. So those are gone. And then my last one is the square root of 3 times negative square root of 3, which is plus 3, minus 3. Minus 3. So positive times a negative, so it's negative square root of 3 times square root of 3 is 3. So every time you do this, it will just be that very first group, x minus 1 squared, and then your minus 3, or whatever radical you have in the back, minus 1. Now, expand this. What do I mean when I say expand? Not distribute the x, or the squared. Write it as x minus 1 times x minus 1 and FOIL it out, right? Okay, it is not x squared plus 1 or x squared minus 1 or anything crazy like that. It's x squared minus 2x plus 1. And then I have a minus 3. So then Trevor says that's x squared minus 2x minus 2. And I still have to multiply by x minus 2. Now, we did this in chapter 2 of pre-calculus, and wow, it was a mess. So, this year, the more work you put into this, the better off you'd be next year in second chapter.
What if you're gonna take pre-calculus?
Then you could see it in Algebra 3. I don't know the Algebra 3 curriculum as well. If you take prop stats, I don't know that you would have to do this, but you would need to know how to do
Sorry,
things.
is this just, I was gonna get something else gonna go to pre-calculus?
Most people will. So yes, I make that assumption. But I know that not everybody does.
Is pre-cal harder?
Yes. Most people will. X cubed minus 2x squared minus 2x, distribute my x. Minus 2x squared plus 4x plus 4. Distribute my negative 2. Combine my like terms. X cubed minus 4x squared plus 2x plus 4. There's my polynomial. Now, I went really slow, and I wanted to make sure everybody was okay with the, like, distribution of an x minus 1, and then with the square root thing there. But, like, then my first hour, we were working on problems, and they're like, well, that was not as hard as you made it sound. I agree. It's not as hard as I make it sound. But everybody needs to, like, be alert on that problem and write stuff down and do the algebra. And eventually you'll notice a pattern, and you might not even have to think about FOIL, because it really is just a difference of perfect squares. So when you're there, and you can stop doing all the work. Okay, so totally up to you. Now what's interesting is if right here at this x squared minus 2x minus 2, if you took that quadratic, if you do the quadratic formula, your answer should be 1 plus or minus the square root of 3. Okay, so you can check to see if you have distributed or like multiplied that out correctly by doing the quadratic formula. You should go back to your irrational answer that you had before. Okay, so you don't have a lot of homework assignment or a lot of problems for homework